let's use right triangle trigonometry to solve some application problems. First, there are two vocabulary terms that we want to make note of. One is the angle of depression, and the other is the angle of elevation. So the angle of depression is usually from the top of an object, and then the angle rotating down to, say, look at the ground or another object. And the angle of elevation is often measured from the horizontal on the ground, and then the angle rotates up to look at the top of an object. Let's look at this example. Franny is standing on the ground 30 feet away from the base of a tree. The angle of elevation from where they are standing to the top of the tree is 57 degrees. Determine the height of the tree. All right, so I'm going to start out by making some kind of diagram of the problem. So she's standing on the ground 30 feet from a tree. All right, so here's my tree, and you can add some, foliage or something, but there's my sad tree. Here's our friend Franny, and this person is 30 feet. So, okay, so this length here is 30 feet. I'm going to include my units in my diagram. What else is given to me? Okay, so there's my 30 feet. The angle of elevation from where they're standing to the top of the tree. Okay, so angle of elevation and angle of depression involves some horizontal. So in the case of angle of elevation, I'm starting the horizontal of the ground and then rotating to look up to the top of the tree. Okay, and this is 57 degrees here. And then determine the height of the tree. So I want to assign a variable to the quantity that I am trying to find. So I'm trying to find the height of this tree. So I'll call this H, call it X or A or something else, but I'm just going to use H. And now I have done that. So I have my diagram and I have a variable. The next thing I want to do is set up an equation. And in the equation, I only want one variable, right? So I want to relate, I probably want to use some right triangle trigonometry. Right triangle trigonometry, those equations involve an angle and two sides. So I have an angle that's 57 degrees, and I have two sides. One I know and one I don't know. So of the three components, I know two of them, and I don't know this other one. So that's setting me up for success here. Okay, so here I am, Franny. So for Franny, H is representing the opposite side of this right triangle. I'll put in my right triangle little box down there. And the 30 feet, that length is assigned to the side here. That would be adjacent to where Franny is. And this is the hypotenuse, but I'm not going to need it here. So what equation involves both the opposite and hypotenuse? Oh, sorry, opposite and adjacent. Well, tangent. So I'm going to have my tangent of 57 degrees is equal to the opposite side length, h, over the adjacent side length, 30. So do I have an equation with only one unknown? Yes, because the tangent of 57 degrees is something that my calculator can determine. Now I'm going to solve for my variable. When I do that, I just multiply both sides by 30, so that's not too bad here. And now I have h, and I am now going to solve for this in my calculator. So I'm going to do h is approximately, because it's going to give me an approximation. And I'm kind of ready to put it in this slot. And I'm going to do 30 times tan of 57 degrees in my calculator. When I pull this out, I can do 30 times, and then again, tan of 57 degrees. Okay, so tan of 57. Now I know that I'm in degree mode, so I gotta make sure or else I can mess it up here. And I get 46.2. 46.2. Now I want to write a sentence that kind of summarizes what I found. I don't want to just leave h as approximately 46.2, especially because I came up with this variable h and the reader doesn't know anything about h from the prompt. So I want to finish it with a sentence. What was I trying to define or find in the first place? Determine the height of the tree. Okay, so height of the tree. So I'm going to come back here and say the height of the tree is, and because this other length is given in feet, this will also be in feet. So the height of the tree is 46.2 feet. All right, let's look at one more example. Suppose a 13-foot ladder is leaning against a building reaching to the top of a second floor window 12 feet above the ground. What angle in degrees does the ladder make with the building? Okay, Well, I'm definitely going to need a diagram to kind of figure out what's going on here. I know there's some building and there's the ground, and that the ladder is leaning against the building. Okay, so I'm creating some kind of right triangle, which is good because I'm in my right triangle trigonometry section here. So I'm going to mark that right angle. This is my ladder here, and it has a length of 13 feet. So I'm going to mark the hypotenuse in my triangle as 13 feet because it represents the ladder. Now this is the vertical side here is my building, and I know that this second story window reaches 12 feet up, so I'm going to mark this vertical side length of my right triangle as 12 feet. Okay, boom. And it's asking what angle in degrees does the ladder make with the building? Okay, I've got to go find that one. So that's the ladder and the building, and I'm going to give it a name, and I'm going to call it the variable theta. All right, so now I'm ready to set up my equation. So my equation needs to involve, if I'm using a right triangle trigonometry, right? So if I'm using one of the trigonometric equation, it needs to involve an angle and two sides. So here are two sides that I know. So two of the components I know, and then an angle that I don't know. So that seems promising. So how would I label that if I was a little person standing here at this angle, okay, kind of shrinking down into this little triangle here that I've drawn, and this is the hypotenuse no matter what, but this length that has 12 feet would be my adjacent side. So what equation involves adjacent and hypotenuse? Well, don't forget our trusted SOHCAHTOA, and I see that that would be cosine. So cosine of this angle theta is equal to adjacent over hypotenuse, so 12 over 13. And now I can use my inverse function, cosine inverse of 12 over 13 is equal to theta. So that gets theta on its own side. It kind of gets it out from inside the function to the outside there by using the inverse. So now I'm ready to enter this into my calculator. Again, I'm solving for an angle, so I'm ready for that. Okay. So cosine inverse, I go find that under this other menu here, go back, and I want 12 divided by 13 as the input. When I do that, I get 22.62 degrees. And again, I'm in degree mode on my calculator, so I'm all set there. This is asking what angle in degrees does the ladder make with the building. So I'll say the ladder makes a 22.62 degree angle with the building.